Hi everyone, it's Miss Smith, and I'm here to go over your math room this week. We are going to be looking on page 484, and then we will come to the page that you were working on. But I just wanted to go over how to do this because I heard that we had a lot of confusion on how to do this. So hopefully this video helps you at the end of it. And if you're still confused, don't be afraid to reach out to me and hopefully we can work something out, okay? So I am going to go ahead and share my screen. So then we can get started on this math, okay? So today it's been asking you to figure out a mystery shape using pattern blocks. Unfortunately, we weren't able to send home pattern blocks. So I have the online version here. So I will give you the shapes here and then hopefully that can be used to help you. So again, just to start off, I just want you to get used to covering the shapes here with different pattern shapes. So here we see a picture of a hexagon. Okay, again, a hexagon is a six-sided figure like this. We also have a triangle. This is the green shape right here. We have a trapezoid and we have a rhombus. Okay, so today we are going to be taking these smaller pattern blocks and covering the hexagon completely up. And we want to figure out how many of these shapes it will take to cover up this whole hexagon. Okay, so I'm just starting off with the triangles. Again, I've been having troubles rotating it. So give me 1 second. Again, I want to figure out how many triangles does it take to cover this hexagon. There we go. All right, so far we have 3 triangles, but we haven't covered the whole shape up. We haven't covered the whole hexagon up. So far we have 4. 1, 2, 3, 4. Think about how many more we will need to cover up this whole hexagon. Give me 1 second. It's kind of hard to rotate these. There we go. Okay. And we have 5 triangles. So again, we haven't covered up the whole hexagon yet. So we need to take another one and see if this is going to cover up the whole hexagon here. And you can see, if I had my real pattern blocks, I can show you exactly. But here we can see that it took 1, 2, 3, 4, 5, 6 triangles to cover this hexagon. Okay, I'm just going to refresh that page so then you go back to beginning. So again, that is what we are going to be covering these mystery shapes in. Okay, so let's go ahead and go to this box right here. This is probably more what your homework looks like. So here is going to tell you the number of hexagons. We have numbers 1 through 5. The first one we are going to look at is just one hexagon. Okay, so we're only going to focus on this hexagon right here, not these right now. Okay, so if we have one hexagon, I want to know how many trapezoids, again, that is the red shape right here, how many trapezoids is it going to take to cover one hexagon right here? So let's go ahead and drag over a trapezoid. And I want you to be thinking about how many is it going to take to cover this hexagon. And already you can probably see that it took two trapezoids to cover this hexagon. So down here, or in your work, you would write, for one hexagon, there are 2 trapezoids. For here, where it says how I figured it out, you could just say I covered the pattern blocks over the hexagon. Okay, so I will come back to these 2 in a little bit, but let's go ahead and look at if we have 2 hexagons. Okay, so we already dealt with 1, and there were 2 trapezoids for that. But what if I wanted to look at how many trapezoids there are for 2 hexagons? Okay, so now I want to focus on these 2 right here. We already know that it takes 2 trapezoids to cover 1 hexagon. So if we have 2 hexagons, let's see what we have. how many is it going to take? And there. Okay, so again, it takes 2 trapezoids again to cover a hexagon. So if we look at these 2 hexagons right here, let's think, how many trapezoids does it take to cover these 2? So we have 1, 2, 3, 4. So it took 4 trapezoids to cover 2 hexagons, okay? So I want you to really think about, what pattern do you see as we are going through this, okay? I'll do one more and then I want you to think about, what do you think we are counting by? What number, okay? So if we have 3 hexagons right here, okay, I need to cover my 3rd hexagon. And I want to be thinking about how many trapezoids in all does it take to cover 3 hexagons. Okay, so let's go ahead and count. 1, 2, 3, 4, 5, 6. It took 6 trapezoids to cover 3 hexagons. Okay, all right, so if we are counting by 2, 4, 6, what number are we counting by? You can also see this, if you're not for sure, that you can count by what number for each hexagon. We have 2, 4, and 6. Okay, so instead of counting by ones like we have been doing, let's go ahead and just count by 2s for this 4th hexagon. So if I have 4 hexagon, okay, that means we want to count by 2s 4 times. Okay, so let's go ahead and count it by 2s. Ready? 2, 4, 6, 8. So we know there are 8 trapezoids in 4 hexagons, okay? So our last step, I want to know how many trapezoids there are in all if I have 5 hexagons, okay? So again, instead of by counting by ones, let's try and count by 2s, okay? So, give me 1 second. Okay, there we go. So let's go ahead and count by 2s. 2, 4, 6, 8, 10. Okay, so we know just by counting by 2s that we have 10 trapezoids. Okay, so for this column right here where it asks you how did you figure it out, you could just say that we use pattern blocks to figure it out. You could also say that you counted by 2s. Okay, you could do either or. And now for the equation, we want to do write an equation. So for the first one, I'm just going to leave blank because I want you to see what it looks like with 2 addends, okay? So if we have 2 hexagons, that shows us that for each hexagon we have 2 trapezoids plus 2 more trapezoids, and that gives us, that gives us 4 trapezoids in all, okay? So if we go here, now we are counting by 2s 3 times, okay? 2, 4, 6. So 2 plus 2 plus 2 equals 6. Okay, let's go ahead and go to, if we have 4 hexagons, we want to count by 2s 4 times. So 2, 4, 6, 8. That gives us 8. So 2 plus 2 plus 2 plus 2 equals 8. And then lastly, to write an equation, if we have 5 hexagons, we have 2 trapezoids plus 2 trapezoids, 2 plus 2 plus 2. That gives us 5. Sorry, gives us 10 trapezoids, okay? So this is just a little warm up to get you ready for your assignment. So let me try and pull up what your page looks more like. Now this is just a little activity. I sent the same copy to your parents. So if you want to cut out these shapes and try and figure which pieces, how many go into a hexagon, that is good practice. So I'm gonna skip over that for now. But again, if you need more help with that, use those shapes, okay? So I'm going to go ahead and refresh this page so that we're at the beginning. And this is more what your work is going to look like, okay? So just like the first problem, we have some number of hexagons right here. We either have one hexagon, so kind of like this, one hexagon, two, and so on. Okay, let me get rid of this one. There we go. But instead of figuring out how many trapezoids it takes to cover a hexagon, we're going to figure out how many rhombuses it takes to cover this hexagon. So just to give you a little visualization, I'm going to go back to this page just so you can visually see it. So just like we did for the last one, I told you don't worry about the one hexagon equation because we want at least 2 add-ins for our equation. So we'll get to this later. I just want you to look at this for now. So for number 1, it wants us to find out how many rhombuses does it take to cover one hexagon. So let's go ahead and figure that out. So again, a rhombus is this blue shape right here. And if you have your cutouts with you, go ahead and follow along, okay? So again, we want to cover this hexagon with a number of rhombuses. Okay, so rotate your pieces so they fit exactly into the hexagon. Hopefully it rotates for me. There we go. See, I should have cut mine out too, so it would have been way easier. Let me see. There we go. And think about how many rhombuses it took to cover this hexagon. There we go. So for one hexagon, it took 3, let me see if I can do this sound. It took 3 rhombuses to cover one hexagon. So I'm going to write in 3 here. So now, if I want to look at 2 hexagons, like here, 2 hexagons, I want to know how many rhombuses altogether there will be for these 2. So again, think about how many rhombuses fit in one hexagon. And you want to be thinking about what number do you think we are counting by? Okay, that's going to help you in the long run. What number are we counting by? Again, I just need to rotate this so it fits perfectly into the hexagon. Here we go. Okay, so now I have 2 hexagons. I want to know how many rhombuses it took to cover these 2. So let's go ahead and count together again. 1, 2, 3, 4. Can't really see that. Okay. There we go. 4, 5, 6. So I can see that it took 6 rhombuses to cover 2 hexagons. Let's do the, if we have 3 hexagons, how many it'll take. Be thinking about what number are we counting by? Okay, so let's go ahead, go back, go back here. Now we're gonna be looking at 3 hexagons. 1, 2, 3. So let's go ahead and drag our rhombus over so that it fits perfectly into our hexagon. And there we go. Again, all of these shapes are going to fit perfectly into a hexagon, but it's going to have a different quantity or a different number value, okay? So now let's look at how many rhombuses it took to cover 3 hexagons. Let's try and count by the number that we are counting by. So here we have 3. Here we also have 3. Ooh, and here we have 3. So let's go ahead and count by 3s, okay? 3, 6, 9. Okay, so we have 9 rhombuses to cover 3 hexagons. And from here, honestly, oops, that is not the right number. I want to write down 9. Good thing I caught myself there. All right, so 9 hexagons means there are 3 hexagons means there are 9 rhombuses. So from here, we can just keep that pattern going. So now if we want to count by 3s 4 times, let's go ahead and count by 3s 4 times. 3, 6, 9, 12. Okay, so we want to be counting by 3s here. And then the last one, count by 3s 5 times here. Ready? 3, 6, 9, 12. 3 more than 12 is 15, okay? So that's how you kind of fill out this chart right here. Now we can go to our equation, okay? So we know that we don't need to do the first one. So for 2 hexagons, we know that in 1 hexagon, oops, that's really off. 1 hexagon is 3. Then we have 2 hexagons all together, so we need to add 3 plus 3 together, and that's going to give us the total number of rhombuses here, which is 6. Okay, so let's try and do, if we have 3 hexagons, how many rhombuses are we going to have? So for 1 hexagon, 3. If we add in another, 3. And if we add in another hexagon, which has 3 rhombuses, it's going to have 3. And if we add it all together, and also we look back here, we saw that 3 hexagons means are going to be 9 rhombuses. Okay, so again, you just need to keep this pattern going. So here we counted by 3s. How many times? We counted it by 4 times. So 3 plus 3 plus 3 plus 3. Try to do on a computer. And plus 3 equals the total number of rhombuses, 12. Okay. And then lastly, if we count by 3s 5 times, that's going to give us 3 plus 3, okay, plus 3 plus 3 plus 3. See, we added 3 together 5 times. 1, 2, 3, 4, 5. And that gives us the total number of rhombuses, which is 15. There we go. Okay, so again, that's going to be a little bit more like your work that you were assigned to. I'm going to go ahead and do this one together with you, okay? So this is mystery shape number 1. I believe you were assigned mystery shape number 8 and maybe another one, but this is going to be more like what you are working with, okay? So for a number of rhombuses here, so now we're not covering rhombuses, we're covering, we're not covering hexagons, we're covering rhombuses, okay? But we don't know what shape we're using to cover these, okay? So we have to figure out what shape we are using to cover the rhombus. However, they do give us one clue. They tell us 2 shapes of something is going to cover 1 rhombus. So let's go ahead and go back here. I'm going to refresh the page. And then, so instead of looking at these, I wonder if I can, no. We go to a different page. See if this will help us. Have to find, oh, here we go. Okay, so let's say, again, we want to know how many of a shape is going to cover a rhombus, okay? We know that and for 1 rhombus, it will take 2 shapes. So I'm just going to go ahead, go through these shapes and see which shapes is going to require 2 to cover the whole shape. So let's go ahead, for sake, let's start with a hexagon. If I take 2 hexagons, does that cover exactly my rhombus? You can see clearly the hexagon is way too big. So the hexagon is not the mystery shape. I'm going to put that back. Let's go ahead and look at the trapezoid. So if I want to try doing the trapezoid, we can see that the trapezoid, again, is way too big for the rhombus, okay? So it's not the trapezoid that's the missing piece. Let's go ahead and look at the triangle, okay? So if ooh is a pretty good fit. So here's one triangle. Again, we need two of a shape to cover this rhombus. And would you look at that? Two triangles cover up a rhombus. So here, when I go back over here, it tells me that it tells me that two of some mystery shape is going to be one rhombus, and we know that that has to be the triangle. So I'm just going to write that in here. You don't have to write this, but just to help you remember. Okay, it's hard to write with this. Again, we know that the mystery shape is a triangle. All right, so let's go ahead. If we have two rhombuses here, I want to know how many of the mystery shape it will take to cover the two rhombuses. So let's go ahead and go back. Okay, so here we know that this is one rhombus, so now it's asking for two. So already you can probably assume that I will need two more of these. Okay, and again, that tells us that for two rhombuses, we need 4 triangles. All right, so let's go ahead and try and figure out this one now. If we have 3 rhombuses, just like we have here, how many of our mystery shape, which we know is a triangle, are we going to need to cover 3 rhombuses? So let's go ahead and get another rhombus. Okay, we want to figure out how many of the mystery shape, which we already kind of know that is the triangle, how many it takes to cover 3 rhombuses. So let's go ahead, count together. 1, 2, 3, 4, 5, 6. You could also count by 2s because for each rhombus there are 2 triangles. So 2, 4, 6. So we're gonna go over here, and in this missing box here, we know that it will take 6 triangles to fill in 3 rhombuses. So think to yourself, what pattern do you see as we are counting each triangle? It goes from 2, 4, 6, 8, 10. And most of you can see that we were counting by 2s. Okay, so for each rhombus, there are 2 triangles, 2, 4, and 6. Okay, so it goes from 3 rhombuses. So you can assume if what the next number for the rhombus is, we want to know that if there are 8 triangles, there are going to be 4 rhombuses, okay? And really, without using your pattern blocks, you can probably figure out this last one. If we count by 2s 6 times, what number is that going to give us? Most of you can say it's going to give us 12. Okay, so let me go ahead and write that in, 12. And now for the equation, you can write the number of triangles it took to, or how many rhombuses it took to find out the number of triangles. So if we have 2 rhombuses, we want to think about how many triangles were in one. So we know that in one rhombus there were 2. And then in 2 rhombuses, we know that there were, and another 2. In total, there were 4. Okay, so you want to be counting by 2s this many times. So this next one, we are going to be counting by 2s 3 times. So let's go ahead and count by 2s. 2 plus 2 plus 2. Again, we are adding by 2s 3 times. 1, 2, 3. And that gives us the total number of triangles that we use. So 6. So again, keep this pattern going. Here, we are counting by 2s 4 times, okay? So it's just like we did here, except add 2 plus 2 plus 2 plus 2 equals 8, and so on, okay? So at the bottom here, we can finally state what the mystery shape is, and we said it was a triangle, okay? So again, we want to make sure that the pattern or the shape that you are using is repeated for each step, okay? You can't be using different shapes in order to cover, say, this rhombus. So saying I took that away, I can't use a triangle and I can't use a hexagonal one, okay? It has to be the same shape for this, okay? So remember that. So again, that's pretty much what your math is asking for. Let's go ahead and just take a look at number 8, because I think that was one you had to deal with or solve. So as we wait for that to load. Okay, so here, it doesn't tell you what your shapes are. You have to figure it out yourself, okay? But I will give you a little clue. So for the number of mystery shape A, that's usually going to be your bigger shape. So if we start off with 1 on the mystery shape, say we have 2 of the mystery shape, so on and so on, okay? So 1, 2, 3, 4, 5, 6. Here is where you're going to have to figure out what number is the mystery shape counting by, okay? I'm not going to give you an answer for this one because it was your work, but go ahead and think back to our examples that we did together, okay? That should be able to help you. So let me get out of this. So again, if this was any help for you, I am glad that it worked for you. If it did not, then make sure you let me know and I will try and explain it a little bit better. Okay, but hopefully this was helpful, and I'm hoping to set up a Zoom meeting with you all sometime next week, but I will give you more information about that. Okay, and in the meantime, I hope you're all doing well, and let me know how your days have been. Okay, so I hope to see you soon. Bye.